All right, so number 35, we need to write an equation for the ellipse with foci at 3, 0 and negative 3, 0, and vertices at negative 9 and positive 9, 0. So what we need to notice here is that the foci, these ordered pairs, are on the x-axis, and the vertices are also on the x-axis. So in an ellipse, your vertices and your foci are always on the major axis. Because this is on the x-axis, this means that we are looking at a horizontal major axis. This will be a horizontal ellipse. Now, to write an equation for a horizontal ellipse, I'll just write out what the equation is. It is x squared over a squared plus y squared over b squared equals 1. So if we have our a squared and our b squared, we're ready to write our equation. So the vertices will give us our a value. So if your vertices are at 9 and negative 9, that means that our a value is equal to 9. So we can square the 9 to get our a squared, but we need our b squared. Your foci, these are not b values, these are our c values. So because the foci are at 3, 0 and negative 3, 0, our c is equal to a 3. To find the b value that we need to write this equation, we can use our Pythagorean relation. For an ellipse, your Pythagorean relation is a squared equals b squared plus c squared. And then we can solve that equation for b. So if we plug in our values, a is 9, so 9 squared is 81. B squared is what we need, and our c value is 3, so 3 squared is 9. We can subtract 9 from both sides, and we get a b squared equal to 72. Now we could square root both sides to figure out what b is, but I'm going to put b squared in the equation anyway, and b squared equals 72. A squared, if a is 9, a squared is 81, and that's going to go in our equation. So our equation of this ellipse is going to be x squared over our a squared is 81 plus y squared over our b squared is 72, and then it is equal to 1. All right, let's practice some graphing. Number 36, graph this function. Well, does not tell us what it is, so we have to take a look at this equation and see what we recognize. First, it's set equal to 1, so this is probably going to be an ellipse or a hyperbola. And then because of the addition sign, that's going to have us narrow it down to an ellipse. All right, so in an ellipse, let's just remember a couple things. Our a squared is always going to be the larger denominator. That's going to be that 25. So our a squared is 25, which means that a is 5. That's where our vertices will go. Our b squared is that smaller denominator of 9. So if b squared is 9, that means that b is a 3. And then we just have to figure out if this is a horizontal, if this ellipse has a horizontal or a vertical major axis. Well, we can see that our a squared 25 is below the x squared, which is a horizontal axis. So this is a horizontal, or this ellipse has a horizontal major axis. So we are going to plot our vertices on the x-axis and our co-vertices on the y-axis. Your vertices are your a value. So from the origin, we're going to go to the right 5 units, to the left 5 units. Those are our vertices. Our co-vertices are our b value. Those will go on the minor axis. So I'm going to go up 3, down 3. That's going to give us the shape of our ellipse, so we can draw in our ellipse, but we don't want to forget that there's another piece of information that ellipses have, and that is the foci. Your foci is going to be, we plot that using our c value, and our c value, or the foci is on the same axis as your vertices. So the foci go on the major axis. We do not know what our C value is, but we can find it using the Pythagorean relation. So if we, let me move this. There we go. Need a little space over here. So our Pythagorean relation for an ellipse is a squared equals b squared plus c squared. We up here said that a squared was 25, so 25 is equal to b squared is 9 plus c squared. Subtract 9 from both sides. 25 minus 9 is 16 is equal to c squared. If you square root both sides, then c is equal to 4. So in our ellipse, we can go ahead and plot the foci, again, on the same axis as your vertices. So we're going to go 4 to the right and 4 to the left. Let's go ahead and label that F and F for our two foci. So there is our graph of an ellipse. All right, let's continue on. Let's see, that was 36. I'm going to go down to number 37. Graph x squared plus 5y squared equals 25. Okay, so we have a little bit of work to do with this equation. We can see that we have, we're adding these two terms together equal to 25. For this to be an ellipse or a circle, we do need this to be equal to 1. So to get this equal to 1, all we have to do is divide this 25 by itself. 25 divided by 25 is 1. Then we'll have our equation set equal to 1. But if we're going to divide that by 25, we do need to divide everything by 25. This is going to give us a new equation to work with. We have x squared over 25 plus, now this 5y squared over 25, the 5 over 25 will reduce to 1 over 5. So y squared over 5 equals 1. Now we have our equation. We have our x squared over 25 plus y squared over 5 equals 1. So this is an ellipse. I don't know if we said that already. All right, so in an ellipse, our a squared is the larger denominator. So a squared is 25, which means that a is 5. B squared is equal to 5, so b is the square root of 5. And then just for when we get to our graphing, that's about equal to a 2.2. All right, so this ellipse has our a squared below the x squared, so that means that the x-axis is our major axis. So our vertices will go on the x-axis. So our vertices are going to be our a value. So we're going to go from the origin 5 to the right, 5 to the left. Those are our vertices. The co-vertices are our b value. Those go on the minor axis. So that square root of 5, which is about 2.2, we'll estimate up about, that's about 2.2. I'm going to go down about 2.2. We can go ahead and draw in our ellipse, but we don't want to forget, we're going to add in also our foci. Foci are going to use the c value, so we need to use the Pythagorean relation to find our c value. So Pythagorean relation for an ellipse is a squared equals b squared plus c squared. Our a squared is 25. Our b squared is 5. And now let's solve for c. Subtract 5 from both sides. 20 is equal to c squared, so c is equal to the square root of 20. And then when we square root that, that's about equal to a 4.8. So we can go ahead and plot our foci on our major axis. They're going to go same axis as our vertices at about a 4.8. So we're going to go over, man, that's even hard to see. That's really close to the vertices. That's where our foci is. I am estimating a 4.8. All right, now we can jump over to number 38. when we take a look at this equation, we have to graph y squared over 16 minus x squared over 25 equals 1. So the thing we want to notice here is the subtraction. This subtraction is going to make this a hyperbola. So a hyperbola, if you look at your formula sheet, the a squared is always out of the first fraction. So that's our a squared. So a squared is equal to 16, which means a is 4. Our b squared is the other denominator. B squared is 25. So our b value is 5. Now, because our a squared is below the y squared, that means that the y-axis is vertical. This is a vertical hyperbola. It has a vertical transverse axis. So we'll just make a note that this is vertical. What that means for graphing is that our vertices are going to go on the vertical axis. Our vertices are going to be plotted using this a value. So from the origin, I'm going to go up 4, plot a point. I'm going to label that as V for vertex. I'm going to go down 4. There's another vertex. These graphs have asymptotes. So for a vertical transverse axis hyperbola, the asymptote equation is y equals plus or minus a over bx. So these are just two equations of lines. Let's go ahead and find one of them. One asymptote is y equals, our a value is 4, our b value is 5, so y equals 4/5 x. When we graph that line, it's going through the origin, and the slope is 4/5, so we go up 4 over 5, up 4 over 5, and then we'll reverse that the other way, down 4 over 5, and down 4 over 5. And we can go ahead and sketch in this asymptote. Just remember, the asymptote helps us guide our curves for our hyperbolas. The other asymptote is y equals negative 4/5 x. So that plus or minus just allows us to break this into two separate lines. So this one also goes through the origin, and instead of going up 4 to the right 5, it's going to go down 4 to the right 5, and down 4 to the right 5. And we'll continue that line. Go ahead and sketch in the other asymptote. All right, so right now we do have enough information to draw in these two curves. So your hyperbolas do go through the vertex and they head toward the asymptote, getting closer, never touching it. They approach asymptotes. We can go through the other vertex. We can kind of see how wide these end up being. Now, another thing that is part of a hyperbola are the foci. Foci uses the c value, and we have a Pythagorean relation for hyperbolas. This one is c squared equals a squared plus b squared. So I'll go ahead and write that. C squared equals a squared plus b squared. So our c squared is, let's see, our a squared is 16 plus our b squared is 25. So 16 plus 25 is 41. So our c value is the square root of 41. Square root of 41, let's see, that is about equal to 6.4. So your foci go on the same axis as your vertices. We're going to go 6.4 units away from the center, the origin. So if we go up 6.4 units, put an F next to that to indicate the foci, and then from the origin, we're going to go down 6.4 units for the other foci, the other focus. All right, so there's a nice looking hyperbola. All right, so we've got one more graph to work on this page. Graph 5x squared minus 9y squared equals 45. So I do notice the subtraction. So this is probably going to be a hyperbola, but it's not set equal to 1. So we do need this to be equal to 1 in order for us to graph this. So similar to the problem to the left, number 37, we can get this equal to 1. You know, we can manipulate this equation if we just divide by 45, which means we're just going to divide everything by 45. When we do that, we're going to have a new equation to work with. 5x squared over 45. This 5 over 45 reduces to 1 over 9, so that's going to be x squared over 9 minus, now this 9y squared over 45. 9 over 45 reduces to 1 over 5, so y squared over 5 equals that 45 divided by 45 is 1. All right, so this is the equation we're going to graph. All right, so with a hyperbola, the a squared is always going to come out of that first fraction. So a squared equals 9, which means that a is 3. Our b squared is coming out of the second fraction, so b squared is 5. So b is equal to a square root of 5. And we saw that, I think in the last one, that's about equal to a 2.2, if we need to use that for any graphing. Because our a squared is below the x squared, the x is a horizontal axis. This hyperbola has a horizontal transverse axis. So that means that our vertices are going to go on the horizontal axis. So we can go ahead and plot those from the origin. We're going to go to the right 3. Let's label that with a V for vertex. To the left 3, label that with a V for vertex. We can go ahead and get our asymptotes. So our equation for an asymptote with a horizontal transverse axis is y equals plus or minus b over a. So this is going to get a little messy here just because our b value is a square root of 5, or about a 2.2. So one asymptote is going to be y equals, our b value is that square root of 5 over our a value is 2x. So when I graph this, that square root of 5, that square root of 5 over 2, that's my rise over the run. So I am going to rise the value of square root of 5. So I'm going to rise 2.2 and run 2. Rise 2.2 and run 2. So I am doing some estimating on this. So from the origin, this line asymptote will go through the origin. I'm going to go up 2.2 and over 2. Then I'm going to estimate up 2.2, oops, don't forget to go over 2. Now I'll go down as well. So down 2.2 over 2, down another 2.2 over 2. So we can see that we're getting there's one asymptote. We can form a line out of those. The other asymptote is going to be y equals a negative square root of 5 over 2. So same idea, this time we're going to have a negative slope. So from the origin, we're going to go down 2.2 over 2, down 2.2 over 2. I'm just getting a few points on here just because that 2.2 is kind of a pain to graph. To get the left side of this line, up 2.2 over 2, up 2.2 over 2, about there. So that's pretty good. We can draw in an asymptote through these points. Okay, so because this hyperbola has a horizontal transverse axis, that means that our hyperbola is going to go through the vertex, but these hyperbola curves are opening to the left and right horizontally versus the up and down we just saw. So it does go through the vertex. It's going to look like that. And then what else do we need on this graph? We also need the foci. So the foci we're going to find with a Pythagorean relation. Pythagorean relation for hyperbolas. is c squared equals a squared plus b squared. So, and we're trying to figure out the value of c. That tells us where to put our foci. So our a squared is 9, our b squared is 5. So c squared is equal to 9 plus 5, which is 14. And that makes c equal to the square root of 14. Now the square root of 14 is about equal to 3.7. So when we come back to our graph, we're going to plot our foci at about a 3.7. There we go, trying to get the right color. So from the origin, your foci are on the same axis as your vertex. So I'm going to go to the right 3.7, which is about there. There's one focus. And I'm going to go to the left 3.7. Oh, this got sloppy over here. There's the other focus. And you can't even see that green, but hopefully you guys get the idea. All right, we've got our last problem on this page. Number 40 says, below there is an equation of a hyperbola, ellipse, and circle. Label which is each. So first of all, the hyperbola has something very special about the equation. Hyperbolas are the ones with subtraction. So if we look at our three equations, this one has addition, addition, here's that subtraction. So this one is going to be the hyperbola. So if you have a question like this, identify hyperbolas with that subtraction. Okay, so between the other two equations, how do we know which one is a circle and which one is an ellipse? So these equations look pretty identical. The difference is this one has a 16 and a 16, and this one has a 12 and a 16. So if we look at this 12 and the 16 for an ellipse, oh, and there's also a typo. Do you guys see it? This should be a y squared. Okay. So for an ellipse, what you want to remember is the shape of an ellipse it's elongated. You know, one, I want to say side of the ellipse, but that doesn't even make sense. So, you know, you can have an ellipse that is longer horizontally or longer vertically, that major axis. And so what makes one side or one direction longer than the other one? That happens when these are different numbers. All right. If these two numbers are the same, that means that your major and minor axes are the same, which gives you a circle. So between these two, one is a circle, one is an ellipse. If these two numbers are different, this 16 is your a squared, and that's going to elongate, that's going to make your major axis vertical. That's going to be the longer axis. So this one is an ellipse. And if these two numbers are the same, then, and it has that addition in between, this one is a circle.